Welcome to myprojectbazaar.com.
Title of our product is a compact 1-pin mode transition circuit for clock synchronization in current mode controlled switching regulator. Now we are going to discuss about the abstract of our product. This process describes a 1-pin mode transition circuit that addresses the issue related to clock synchronization in switching regulators during the mode transition between external timing resistor and external clock. The proposed circuit reduces the circuit complexity needed to achieve mode transition during synchronization by utilizing the switched capacitor and sampling design techniques. It linearly converts the input clock frequency to a current to maintain constant amount of slope compensation for current mode switching regulators across their switching frequency range of operations. The experimental results are presented from peak current mode buck regulator with 1-pin synchronization circuit to show the performance improvements of using the proposed design approach over a base lock loop based design. In this process, the rising edge of each pulse starts a new clock cycle for the switching regulator. The small size of the proposed design also makes it possible to reduce the die area of the synchronization circuit. Using the circuit by itself in the switching regulator employed in multi-rail systems where multi-phase clock information is not needed. Now we are going to discuss about the flow diagram of our product. The proposed design is composed of an RT amplifier, a sampling circuit, a detector, a frequency to current conversion, an oscillator, a multiplexer, a pulse generator, and a slope compensation circuit. These are all the modules to implement our flow diagram. The multiplexer is used to select between the clocks generated by the oscillator and detector circuit. The decision to switch between these clocks is made by the detector circuit depending on the state of the RT bar clock pin. The output of the multiplexer circuit is used by the pulse generator circuit to create short duration pulse in response to rising edges of the selected clock. The adder module are used to adding the both sampling modules. One of the sampling output is directly applied into the slope comparator. They are called as an high slope comparator. This slope comparator is a final output of our product. They are come from the pulse generation unit. The input signal is applied into the RT amplifier. They are sampled by the sampling and then they are applied into the oscillator. The oscillator contains different module inputs. They are sampling adder input and another one is a detector input. They are directly applied into the multiplexer. This multiplexer output is directly applied into the slope comparator via pulse generation unit. They are all the flowing procedure of the 1-pin transition mode circuit. Now we are going to discuss about the running procedure of our product. Our product can be implemented by using a LT-Spice 11 version tool app. Double click to open this tool window to create a new file from a file option. In our product we are named as a slope comparator. Our product can be implemented using the slope comparator schematic. Now we are going to see the input signal. Save to run our product. Now we produce the output waveform. After running we will go to measure the input and output. In order to measure the input output waveform using this probe, Now we'll produce the output waveform in slope comparison option. This is an input waveform of our product. This input waveform is directly applied into the frequency to current conversion block, and they will apply to the sampling circuit. The sampling circuit produce an output. Now pick the probe into the sampling unit. This is a sampling output signal. Both are the same for a first sampling and second sampling answer. They are added using the add option. The added sampling signal is directly applied into the oscillator. Pick the probe into oscillator output signal side. This is an output of the oscillation unit. The input will be clock signal. The oscillator will produce the inverse clock signal. Now we are going to see the mux output signal. Vmax is on a mux output signal. The Vmax is obtained by using the sync and S2 input signal. This mux signal is directly applied into the pulse generator unit. They will produce the final output waveform via slope comparator. Now we are going to see the slope comparator output waveform. This is a final output waveform of slope comparator. This slope comparator will produce the sawtooth waveform. This sawtooth waveform is fully depending on the second sampling output signal, I slope comparator. They are all the learning procedure of the one-pin mode transition circuit. Thank you for watching this video.